Math 2 students, I hope you're ready to do problem number 20 from last night's homework. In problem number 20, they want us to find standard form, intercept form, the x-intercepts, the y-intercept, the vertex, the domain, and the range of this function right here. Well, this function has an a value of -2, a b value of -4, and a c value of 30. So I know that function has to be in standard form. So my standard form equation is the equation they gave me in the problem. All right, my next job is to find out what that equation would be if it wasn't in standard form, but if it was in intercept form. So when I look at this thing, I see that it's a trinomial, and I see the a value is not 1. So there could be a greatest common factor. So I have to check to see, is there a number that goes into 2 and 4 and 30 evenly? There is. The number 2 is the biggest number that goes into 2 and 4 and 30 evenly. And then whenever your a value is negative, you have to have a greatest common factor that's negative. So the next step of my problem will look like this. Y equals, and I've determined that my greatest common factor will be -2. Now, if I take every term in my trinomial and divide it by the greatest common factor, I'll know the remaining trinomial that's left in the parentheses. So -2 divided by -2 is +1x squared. -4 divided by -2 is +2x. And +30 divided by -2 is -15. Now, one of the hardest things about factoring is, when do you know if you're done or not? Well, on this problem, I look at this trinomial and I see that it has an x squared. So I have to at least try to factor it. Maybe there is no way to factor it, but we have to find out. So I'm going to continue on trying to break up that trinomial into its binomial factors. And now that we've taken out the greatest common factor, our a is 1. And when your a is 1, there's no greatest common factor. And we have this advantage. We know that we just need to find a pair of numbers that multiply to 15, but add or subtract to 2. So I'm going to start out by putting an x here and an x here, and then listing the possibilities. 1 times 15 or 3 times 5. Now, 1 and 15 is not a good choice because it could add to 16 or subtract to 14, but it's never going to make 2. With 3 and 5, it could add to 8, but it could subtract and come out to 2. So that's the combination that we want to use, 3 times 5. Now when we look at the signs, we need to remember, anytime that you have a negative c, you have different signs. So we're going to have one positive and one negative. But our b value in the middle is positive. So that tells us we want more positives than negatives. So I'm going to make my 5 positive to match the b value, and I'm going to make my 3 negative. Now I'm going to quickly FOIL to check and see if I have it done correctly. So x times x is x squared. The outers make +5x. The inners make -3x. And the lasts make -15. So since +5 and -3 come out to +2, my b value that I'm looking for, I know that I've done this problem correctly. So the intercept form of my equation is y equals -2 times the quantity x minus 3 times the quantity x plus 5. Now that I have the advantage of having standard form and intercept form, I can use those to find the intercepts. The x-intercepts are the solutions to this equation. Or in other words, it's the x value when the y value is 0. And we've learned that since there's no coefficient, we can just use the opposites. So on this problem, my x-intercepts will be 3 and -5. All right, for my y-intercepts, I'm not going to look at intercept form, I'm going to look at standard form. Because in standard form, whatever your c value is, that's your y-intercept. So my y-intercept is at +30. Now, to find the vertex, there's 2 ways that you can do it. You can use standard form or you can use intercept form. If you use standard form, you will need to use that equation there to find the x-coordinate of your vertex. If you use intercept form, you will want to use this equation to find the x-coordinate of your vertex. And remember, P and Q are your x-intercepts. So I'm going to quickly do the problem both ways. This is going to be negative b over 2a, which is negative 4, and a is negative 2. And so that'll make 4 over negative 4, which is negative 1. So if I use standard form, it says that the x-coordinate of my vertex is negative 1. If I use intercept form, I'm just supposed to take the two x-intercepts and add them up and divide by 2. And as you would suspect, that also comes out to negative 1 because both of these functions will give us the exact same graph. So they'll have the exact same vertex, and our vertex will have an x-coordinate of negative 1. Now, to find the y-coordinate of the vertex, we just have to take our negative 1 and either plug it back into standard form or plug it back into intercept form. I'm going to use intercept form this time. So I have y equals negative 2 times x minus 3 times the quantity x plus 5. And now I write y equals negative 2, empty bracket minus 3, empty bracket plus 5. And I'm going to substitute in my x value where the x's are in the equation. So that's minus 1, and that's minus 1. So I have y equals negative 2 times negative 4 times positive 4. And so that'll be y equals positive 8 times 4 is positive 32. So the y-coordinate of my vertex is positive 32. All right, for the domain, we will always have all real numbers. And for the range, we better make a quick sketch of our graph. So our vertex is at negative 1 comma 32. And since our a value is negative, our parabola opens down. And so all of the y-coordinates of every point on the parabola are going to be below 32. And since it opens down and all of the y-coordinates are below 32, we'll write y is less than or equal to 32. And that will be our range. So on this problem, we started out and we knew what it was in standard form. We factored it to find what it was in intercept form. We used intercept form to find the x-intercepts, and we used standard form to find the y-intercept. Then we used this equation with standard form and this equation with intercept form, and they both came out to the same number. That is the x-coordinate of our vertex. Then we took that x-coordinate and I plugged it back into intercept form. I could have used standard form, but I used intercept form on this problem. And I found out the y-coordinate of my vertex is 32. The domain for all parabolas is all real numbers. And the range on this problem is that the y-coordinates will all be less than or equal to 32. Now we're going to take a look at problem number 12 from Friday's assignment. Use zeros to graph the function f of x equals the quantity x plus 3 squared. Zeros. We need to learn that solutions to a quadratic function and zeros of a quadratic function and roots of a quadratic function and x-intercepts of a quadratic function are the same thing. So we've been graphing by looking at the x-intercepts, and now they're asking us to graph by looking at the zeros. These problems are the exact same problem. They're just changing the vocabulary on us a little bit. So on this problem, we want to graph the function. So I'm going to start by writing it in intercept form. So that'll be f of x equals x plus 3 times x plus 3. Now I know if I want to find the x-intercepts in intercept form, I just have to find the solution to this equation. what are the x values when the y value is 0? And I know because there's no coefficients in front of these that I can just use the opposites. So it looks like my x-intercepts are the same. This is called a double root. So my x-intercept is going to be -3 on the graph. But that's the only point that I know. That is my x-intercept. If I want to find the vertex, I can go x equals p plus q divided by 2, and that'll be -3 plus -3 divided by 2, which is -6 divided by 2, which is -3. Well, that's where I already am. If I take this and I put it back into my problem, it will be y equals -3 plus 3 squared. So y equals 0 squared, which is 0. So my vertex is -3, 0. And that's the only place where my parabola is going to touch the x-axis. So my x-intercepts and my vertex are the exact same thing on this problem. So I only have one point. I can't make a graph yet. So in order to make the graph, I'm going to have to make a table. So I'm going to start out like this. And I'm going to take my vertex, -3, 0. I'm going to put it right in this middle spot. And then I'm going to go to -4 and down to -2 and to -5 and to -1. Now I'm going to plug those numbers in to my original equation, and I'm going to find out what my y values are going to be. Remember, the one thing that we know is that these two are going to be the same and these two are going to be the same. So I'm going to put my -1 into the problem, and it'll look like this. So I have -1 plus 3. -1 plus 3 is 2, and 2 to the second power is 4. So when I put -1 in, I got 4 out. And so if I put -5 in, I'll also get 4 out. Now I'm going to try the same thing with the -2. So f of -2 equals -2 plus 3 squared. So f of -2 is -2 plus 3 is 1 squared. So f of -2 is 1. So when I put -2 in, I get 1 out. And so if I put -4 in, I will also get 1 out. Now instead of having only 1 point, I have 5 points that I can put on my graph paper. So I go to -1 and up 1, 2, 3, 4. And I go to -2 and up 1. And I go to -3 and up 0, -4 and up 1, -5 and up 4. And my graph will be a smooth parabola that looks like this.